Welcome to Cant Academy. My name is Marco and I'll be explaining to you proof of mathematical induction. As the name suggests, it is a way of proving if an equation is true. In the case of mathematical induction or PMI, it is a two-step process that proves if a statement P of n is true for every natural number n. Before jumping into solving equations, however, we must take note of the two steps of PMI. The first step, or the base step, just makes sure that the statement is true for every natural number n. In this step, we just assume n is a natural number and solve the equation normally to see if both sides will match. Once that is done, we proceed to the second step, or the induction step. This step is a little more complicated as we will be proving for every natural number n. If the statement for n holds, then it holds for n plus 1. Basically, in the induction step, we will replace the variable n with k such that n is equal to k, giving us p of k. Once we have written down p of k, we must verify that for every k, such that k is greater than or equal to 0, if p of k holds, then p of k plus 1 must hold. This means that we must prove that p of k plus 1 must be equal to one another, just like p of k. Now that we know how PMI works, let's try to apply it in an equation. The general formula for the sum of all natural numbers is 1 plus 2 plus all the way to n, which is equal to the product of n and the sum of n plus 1, which is then divided by 2. Using PMI, let's solve if this equation is true. So let's proceed to the first step, which is the base step, which is to substitute a value of n by a natural number. For this equation, let's use 2. So in the left side of the equation, we will have 0 plus 1 plus 2, and in the right side of the equation, we would have 2 times the sum of 2 plus 1 over 2. Simplifying both sides, we will both have 3, which means the first step, or the base step, is proven to be true. Let's now proceed to the induction step. First, we need to obtain p of k, which is obtainable by just replacing n in p of n with k. Doing so, we will get 1 plus 2 plus all the way to k is equal to the product of k and the sum of k plus 1, which is then divided by 2. Now that we have obtained p of k, and knowing that we have proven that p of n holds, we know that p of k holds. Since p of k holds, we must prove that p of k plus 1 must hold. But before that, let's find p of k plus 1. In the left side of the equation, we just add k plus 1 after k, and in the right side of the equation, we just replace each variable with k plus 1, meaning that in the right side of the equation, we will have k plus 1 times k plus 1 plus 1 over 2. Now that we have obtained p of k plus 1, let us prove that this statement will hold for all natural numbers. Let us simplify the equation. As you guys can see, a certain part of p of k plus 1 is similar to p of k, which is the portion of the equation where 1 plus 2 plus all the way to k. This is simply equal to k times k plus 1 equal to. So substituting that, the left side of our equation is now k times k plus 1 over 2 plus k plus 1. K plus 1 is not a like term, so let's make it a like term by multiplying both the numerator and denominator by 2, which we will now have k times k plus 1 plus 2 times k plus 1 over 2. We can simplify that further because each term in that fraction has a like term of k plus 1. So factoring that, we would have k plus 2 times k plus 1 over 2. Now simplifying the right side of the equation, we can see that there is a term of k plus 1 plus 1. Simplifying that, we would have k plus 2. Now that we have simplified everything, let us see if the equation holds. The left side of the equation is equal to k plus 2 times k plus 1 over 2. The right side of the equation is k plus 1 times k plus 2 over 2. As we can see, both sides of the equations are the same. Therefore, using PMI, we have proven that the general formula for the sum of all natural numbers is true.